I want to look at some examples that require chain rule. And so here we want to find y prime, where y, part A, y equals x over the square root of 7 minus 3x. So another way to write this is that 7 minus 3x is to the 1/2 power here in the denominator. Okay, so usually square roots are easier to work with in calculus, treating them with rational exponents. Alright, so when I take the derivative, I need to first use quotient rule. So quotient rule, again, is low. So that's going to be 7 minus 3x to the 1/2 power times the derivative of the top, which is just 1, minus the top, which is x, times the derivative of the denominator. And this will require chain rule. So that's going to be, so remember the way this works. If I take the square root of 7 minus 3x, you need to identify your parts. So the outside part is my square root, and the inside part is what's inside. Okay, so with chain rule, I need to take the derivative of the outside part, so that's 1/2, leave the inside alone for the moment. So that's 1/2, 7 to the minus 3x power to the negative 1/2. Now when I'm done with the outside part, I move inside, and I need to take the derivative of 7 minus 3x, which is just negative 3. So there it is. And all of this, because of quotient rule, is over 7 minus 3x to the 1/2 squared, which is the 2/2 power, which is just 1. So I just have 7 minus 3x. Okay, so just to clarify this, we have low, d high, high, which is the x here, and all of this is d low. And then here we have low squared, and that's quotient rule. And in quotient rule, we had to apply chain rule as well. Now, how do you clean this up from here? I don't like the negative 1/2, so what I'm going to do is I'm going to multiply 7 minus 3x to the 1/2 power in the numerator and the denominator. So when I distribute that across the numerator, distributing it across here, I end up with 7 minus 3x to the 2/2 power, which is just 7 minus 3x, minus, or we should say plus, 3/2 x is 7 minus 3x to the 0 power. So all of that will just go away. This will all go away and just become the value 1. In the denominator now, I have 7 minus 3x to the first power times 7 minus 3x to the 1/2 power. So you add those exponents, 1 plus 1/2, you end up with the 3/2 power. Okay, so that means we end up with 7. We have a minus 3x plus a 3/2 x. So that's going to give me, this is 6/2 x, negative 6/2 x plus 3/2 x. You end up with a negative 3/2 x all over 7 minus 3x to the 3/2 power. Okay, now lastly, if you want to get rid of the 3/2, we apply the same trick we did here. I'll just multiply by 2 over 2. So I end up with y prime equals 14 minus 3x all over 2 times 7 minus 3x to the 3/2 power. Okay, let's look at another one. Alright, so now we have y equals the square root of t over t squared plus 4. Again, remember, we want to treat this as t over t squared plus 4 all to the 1/2 power. So now when I take the derivative of this, I do chain rule, and then I'll have to do quotient rule, because the outside is the 1/2 power, the inside is this rational expression. So in chain rule, you first say the derivative of the outside, so that's 1/2 t over t squared plus 4 to the negative 1/2 power times, and now I'll have to do quotient rule, which says low, t squared plus 4, times the derivative of the top, which is 1, minus the top, which is t, times the derivative of the denominator, which is 2t, all over t squared plus 4 quantity squared. Now, to simplify this, what I can do here is I can realize that I have a t squared plus 4 to the negative 1/2 times a t squared plus 4 to the second power. So I can add those exponents. My denominator is going to be a t squared plus 4 to the 2 minus 1/2 power, which is the 3/2 power. I also have that 1/2, so I can just say a 2 in the denominator there. In the numerator, I have a t to the negative 1/2 power times, what do I have? I have a t squared plus 4 minus 2t squared. So you could say this as 4 minus t squared, right, by combining your like terms. Now again, we don't like the negative 1/2 here, so to get rid of that, I will multiply t to the 1/2 over t to the 1/2, and I end up with, when I distribute that across, I end up with t times 4 minus t squared all over 2 t to the 1/2 times t squared plus 4 to the 3/2. Okay, and that's probably a pretty good job of factoring it. You could take it a little further if you want, but I think that works. Alright, let's look at one more. Okay, this time we have y equals cotangent squared of sine theta. So when I'm applying chain rule here, we have to identify our parts, and sometimes with trig functions it's easier to think of these. For example, this one is cotangent of sine theta quantity squared. That's what the exponent 2 means here. So now if I'm applying chain rule, my outside part is actually the squared term. The middle part would be the cotangent, and my most inner part here is the sine. So now when I take the derivative, y prime, first you deal with the outside, so that's going to be 2 times, leave everything else alone, cotangent sine theta to the first power. Okay, so that takes care of the first part. Now I have to deal with the second part. The derivative of cotangent, you might have to look it up, but that's negative cosecant squared. Leave what's inside alone. So that's going to be the sine theta there. That takes care of the second part. And then lastly, we have the third part, which is the derivative of sine, which is cosine theta. And so there's the third part as well. Trig functions, it can be kind of confusing at times, so I really do think this outside to inside concept can help. Is there any way we can simplify this much? No, not really. Maybe the best thing you could do is take out the negative. So you have negative cotangent sine theta times cosecant squared sine theta times cosine of theta. One thing you may want to try is that, remember, cotangent of x is the same thing as saying cosecant of x over secant of x. So you could say, maybe you could have cosecant cubed sine theta times secant of sine theta times cosine theta. But does that help you any? Yeah, I don't really think it does. I think this is perfectly valid. Alright, so there's 3 examples on how to use chain rule. I hope this makes sense. Please let me know if you have any questions. I'll be glad to help. You really have to think of these in terms of unfolding them from the outside inside. And if you need any more examples, just let me know. Thanks for watching.